Dr. Chacon and my colleagues. Tonight, I'm presenting my mediated lesson on fourth grade equivalent fractions. My name is Holmes. Nice to see everyone tonight. Common Core Standard for NFA, which is operation of fractions, is one of the standards that is critical in fourth grade, where they'll be able to explain why a fraction AB is equivalent to fraction n times A divided by n times b by using visual fraction models. So in fourth grade, they learn about fraction equivalency using visual models and number sense. So students will search for numerical patterns in equivalent fractions and notice that the numerators of equivalent fractions are factors and multiples of each other. This is the only standard in this grade that requires students to recognize, generate, explain equivalent fractions using models. So the standards that are coming thereafter sequence, they're going to move on to comparing and operating with fractions. So what is equivalent fractions? I want you to come on a journey with me. The first recording that I had, the video did not show, even though it played, but it wasn't show when I listened to it. So I will summarize this video. This video is a real life example of equivalent fractions, how it's applicable in real world. Two friends, they had 15 pieces of gold bars and they seemed to fight because whenever they split it up, there's always one remaining. So a friend came up and offered suggestions on how it could be divided equally. So the first piece was the bar that is one whole, and then the other two is two halves, and they have 4/4 and 8/8. So the friend gave one, the big guy, one whole bar, the little guy, two halves. It's like, okay, where are we going? Then he proceeded to give 4/4 to the big guy, and the other guy was like, where's mine? So he gave the little guy 8/8. So if you look at it, so 2 halves equals 1 bar, 4/4 equals 1 whole as well, 1 bar, and 8/8 equals 1 whole. So that means both of them have 2 full bars. That solves the problem. And it's like they never saw it that way. So hopefully that's the connection we want the children to see, that even though we're doing paper and pencil, virtual, but how is it applicable in real world when you have to split stuff up? They split pizza up all the time, pie, candies, and different things, cookies. So hopefully that connection will resonate with them. So the challenge to the children in this math talk is, can they divide, can they split those fraction bars or the gold bars in another way so that the two friends can have equal share? Yes, there is a way. So they will be engaged in discussing and finding a way that they can split it into equal halves. The learning objective here is that the students can recognize and generate equivalent fractions. They'll be able to explain why fractions are equivalent by using fraction models, and they'll be able to justify their conclusion by using a virtual fraction model. And this is all unpacked from the standard. These are the instructional materials and the method of delivery that will be used. Fraction tiles, number line, they have their vocabulary words labeled. They have instructions on how to draw, how to submit their work on Google and take a picture of their work samples, how to use text-to-speech to be able to record their responses. Also, the method of delivery, PowerPoint, YouTube, assessment on Jamboard, audio directions, and Google picture of students' work samples, and Flipgrid, which is wonderful. They can record themselves and post it on Flipgrid. So, how do we unpack vocabulary words for the children? We're launching. We want to activate their prior knowledge. What do they know about the word equivalent? They should be able to tell what they know about the word equivalent. There's the word equal in it, there's the word length in it. That means equal length or equal area. Something that is speaking of something occupying the same area. So hopefully they will be able to do that. They are doing this together with their partner. There's direction on how to use this blackboard and how to communicate with their partners without putting them in breakout rooms if there's no supervision for them. So they're able to communicate, and all the direction is in the speaker notes for them to be able to follow. Then they examine this reading of Robert's claim. Robert's claim that I know that 1/2 is equal to 2/4. And looking at the two diagrams, so the question to the children is, are these diagrams convincing? Why or why not? So, the color is very enticing to look at. The total length of this tape diagram represents one whole. There are two equal parts. One is shaded half. The shaded parts represent 1/2. So the question that I want the children to be focusing on is, do the students believe that Roberto is correct? Do students notice that the shaded area remains the same even if it is cut into two different parts or equal portion? Again, do the students understand that even though if the area is not the same number of size of the pieces that determines the equivalency, so they have to be able, so do they realize that? Do they understand that it is the area, not the number of size of the pieces that determine equivalency? It is the area, same area. So if you look at it, it's the same area that is shaded. That is what determines equivalency. So again, we want to see whether the children are making connection with, real world. If I have $50, how much is that equivalent to, looking at my coins? So I say that, 2/4, yes, 25 is 50 cents. So which is equal to $50, which is 50 cents. So children are able to make connections. They're able to use number lines. They're able to use different tools such as fraction tiles, to be able to explore and find equivalent fraction. Actually, my fraction tiles is on the left side of this screen, but because of the slideshow, it disappeared, because I can actually manipulate it and put it on the board for you to see. But we're going to work with what we have for right now. So these are the questions for the children from Roberto's claim. Then the children would move into the exploration stages. I have 4 different groups. They have 4 different questions. They have tape diagram. They can use tape diagram. They can use fraction kit. They can use number line. They can use fraction tiles, the circles, whichever ones that they want to be able to explore. Is 4/6 equal to 4/8? They can use, this is a link to AutoDraw, because of time for YouTube. I could have clicked on it, but those are the things I'll be doing with the students in the class. They will be able to use that as well. There's direction for them to use the AutoDraw link as well. So they're finding if 4/6 is equal to 4/8, they're able to justify why or why not. Is 2 4/6? Is 2 5/8 or not? And is 3 equivalent to 6/8? Equivalent? Do they occupy the same area, space area? So the expectations and the interactions here, the children are making connection using visual representation of equivalent fraction of numerical representation. They use pictures, words, and numbers to explain why fractions are equivalent. They generate a rule for finding equivalent fractions and follow that rule. They recognize equivalent fractions. So different interactions that are taking place, they are discussing, they are modeling, and they are using representation to further. I will provide them with more models to be able to build sets of equivalent fractions for visual representation, and then for them to be able to write the fractions as numerals, even as they're looking at it. So, and I will have the students describe what they see So the first circle, which is pink, they'll tell you half of the circle is filled. The numeral is 1/2. Now we move to the yellow one. So what happens to it? What did they see? The half is split into half again. That gives 1/4. So 1/4 each, but the shaded area is now 2/4. So is 2/4 equivalent to 1/2? So what happened to the blue one? How many splits was given to the initial half circle here? Because that's our benchmark. This is split into halves. That's why you have fourths. Then this is split into 3 times now 1, 2, and 3. So that gives third, 3, 6, and the whole is 6. And then the green one here is split into 4 times. It's split 4 times now. So if it's split 4 times, it gives us 8. So you see all the lines, 1, 2, 3, and 4. So the whole is 8. So each of them is equivalent to half. So half. So they should be able to look at the patterns. What do they see in the pattern? How can they explain the pattern? So 1/2 times 2, that means times 2, 2, that's 1 whole, gives you 2/4. 1/2 again, times 3/3. 3/3 is 1 whole, that gives you 3/6. 1/2 again, times 4/4, which is 1 whole, gives you 4/8. On and on like that. I think they're saying the same representation in rectangle mode. That finish early can move on and find other equivalent fractions using tape diagram, bar model, and record their work in their math notebooks. And the other students are moving into flexible groups. So flexible groups, some work with the teacher, some are doing work independently, some are working on the computer for enrichment activities, but I get to see every one of them for 15 minutes and be able to see what they're doing. If there's any misconceptions, we're able to clarify any misconception. If there's need to re-engage, we would re-engage so that students can have a grasp and a good understanding of what they are doing and making sure that they are fulfilling the tenets of the objectives for the day. So as I walk around, I observe students that are using fraction tiles, using number lines, students that are using bar model or tape diagram, and then we're able to have a gallery walk and then be able to explain their work, and students are able to be detectives of one another and be able to ask questions and be able to find out that, oh, I didn't know that is that, they're able to construct viable arguments, critique the reasoning of each other by using the standard for math practices. So this is really very effective with the children having a gallery walk. And then they respond in the end to a prompt in their notebook. I know that 1/2 is equal to 4/8 because they give their reasons, they show their work, they have to draw, they have to justify this. So they have a choice of writing in a journal or using a flip grid to record or using a text-to-speech to record their responses. And then the final assessment, which is still ongoing, is on the white interactive board. The student loves to use that a lot, where the learning outcomes again, and then they to look at the problems. Number 1, recognize equivalent fraction. Number 2, can they recognize equivalent fraction as well? And number 3, pass all of them. They're able to draw on their own 1/2, which is a benchmark fraction, and compare with 5/8 and be able to tell whether they are equivalent or not, whether it is greater or less. So if 1/2 is the benchmark, what is half of 8? Is 4/8. So that means 5/8 is greater than 4/8. So 1/2 is less than 5/8. So they're able to draw, they're able to justify, show their work, and use visuals representation to support their reasoning. So in this last one, they're able to compare fraction, record their comparison with symbols, justify their work. So then in the end, they're able to assess themselves. Did I really meet the learning outcomes today? Can I recognize and generate fraction? I don't just do I really fully understand? Do I still need some help? Was it minimal? The children are able to assess themselves. This is the full measurement and feedback. These are the interventions that are going on. The universal design for learning, where children are able to engage, express themselves, and be able to use representations. People that have different learning experiences, imagine bilingual students, what needs to be done. Maybe we need to read and do different examples together. Make sure that, there's anchor charts in the room and the fractions are labeled, and discuss the meaning of equivalency and equivalent, and students have extension work to be able to move forward. So every capture, every data that is being captured help us to determine the next step as to the different types of intervention that will be used for the children. And the miscellaneous, this is the fraction strip that to see that went away in the first slide, and they're able to manipulate and find equivalent fraction. Thank you.